Hello and welcome to the IROS 2020 Microsoft workshop on mixed reality in robotics. In this tutorial, we will show you how to use mixed reality to interact with robots and how you can use these tools in your robotic project. The tutorial will be split in 4 sections. Section number 1 will talk about the Docker containers we provided for this workshop and how you can run them. In section number 2, I'll show you how to build and deploy our Unity project for Android. Section number 3 will do the same thing for the HoloLens or other UWP-based platforms. In section number 4, I'll give you a brief overview about the Unity project itself and where you can start building your features for your robotic project. So now let's jump right into section 1. In this section, we'll talk how you can pull and run the Docker containers that we provide. First up, you'll have to install Docker on your machine if you haven't done that already. You can find more information on how that is done under section 1.1 in our GitHub wiki. Here you can find a list of links for all major operating systems with additional information how to install Docker. As soon as you're done with that, head over to your command prompt of your choice and enter this command. This command will pull the image Jackal from our repository iros2020.azure.cr.io, build it and launch it with this command here. This command is a simple ROS launch command, which I'll describe later in a bit more detail. Now, watch out with mobile data connections because this image is about 3 GB large, so make sure to be in a wireless network. If you hit enter, it will download the image and build a container on your machine. That might take a little bit longer. I have the image locally on my machine already, which is why it was rather quickly. At some point, you will see some output, and if you see Autumn received at the very bottom here, that means that everything seems to have worked nicely. A quick word about the Docker container, about the container itself. This container includes a gazebo simulation of the ClearPath Jackal robot. It also starts a move base node, which is responsible for trajectory planning and collision avoidance. And lastly, it also starts the ROS bridge, which is required for the Unity app to communicate with the other ROS nodes. We are already done with section 1, so now we'll head over to section 2 and learn how to build and deploy Android apps from Unity. In section 2, we'll talk how you can deploy Android apps to your Android smartphone. Generally, there are 2 methods of deploying apps to the smartphone that we'll talk about. The first one is manually loading an APK file to your smartphone and installing it there. The method number 2 is building directly out of Unity and hitting build and run, which will basically do the same thing in an automated way, but requires Unity, which is why we separated both methods. So let's jump into method 1, which is simply manually loading the APK file onto your smartphone. On our GitHub release page, you will be able to download some APK file. It might have a different name than this here has now, but nonetheless, it will be an APK file that you can simply download from there. The next step is to plug in your Android smartphone via USB to the PC and enable file sharing on your Android phone, such that you can access its storage in a Explorer window. Everything you have to do is copy the APK file to your smartphone to some location you can access from your phone, and that's basically it. Okay, so on your phone, head over to the file explorer you usually use and navigate to the location where you copied the APK file to. In my case, this is this one here. Then type the APK file once, answer the question with yes or continue, and install the application. As soon as this is done, you can see the application popping up on the home screen, or however your phone behaves in this case. You might have to enable installing APK files in your Android settings.
This is a little bit different for all Android versions and from all suppliers, but it's not hard to find out how that is. That is usually somewhere in the security settings. And now we can launch the app.
Okay, in method 2, we learn how to build and deploy an Android app directly out of Unity. For that, first you'll of course have to install Unity. In our GitHub wiki, under chapter 1.1, installing required components, you can find the section 1.1.2, where we collected all the necessary links on how to install Unity. For deploying to Android without editing the actual Unity app, you will not have to install Visual Studio, only Unity or the Unity Hub. So as soon as you have done that, clone the repository or download it or however you usually do it, and make sure that it is at an accessible location on your PC. Then open a Unity Hub window, click Add, navigate to the location where you cloned the repository to, and click the Unity app directory. The name currently is MSMR Demo 2. It might be called a little bit different later on, but it will be pretty clear which folder you'll have to select. Hit Select Folder, and you will see the app popping up in this list. It usually also detects the current version. If not, you can click this drop-down button and select version 2019.4.10f1. If you don't have this version installed, you can head over to Installs and click Add and select a version. If the version isn't even in this list, you can further go to Download Archive, where you can select each and every single version that has ever been released by Unity. As soon as the installed version is shown here, click Add Modules and make sure that you install Android SDK and NDK tools and also open JDK in order to have a complete Android build support. This is necessary to build and deploy to Android smartphones. Since I have that installed already, I won't do it now. That might take a while. If you have done that, you can head over to the projects list again and open the MSMR Demo 2 that you just cloned. Opening the project, especially for the first time, might take a while, so sit back and relax. Okay, my Unity app, my Unity has now finished loading, and you should see a view which is pretty similar to this one. On the top left side, you can see your project architecture, which is more or less an explorer. On here, you can see the scene view, a few other tabs, which we will not go into detail right now. The first thing you'll have to do is click on the file thing and then go to build settings. On build settings, make sure that you have these 4 scenes checked: the manager scene, demo 2 scene, one of the default lighting scenes, and the configuration scene. Normally it will be selected like that already, but if not, you now know which ones to select. Also make sure that the manager scene is the topmost in this list. If it's not, you can just drag them around such that it is the top scene. The top scene will be used as a startup scene, so that is why it is important that this scene is in the top here. Now down here, you can select the target platform. If you have installed the Android build support and you click on Android, you will see these settings here. If you cannot see them, you probably didn't correctly install all the items for Android. In this case, you will see a button which tells you to install the build support, which will open the Unity Hub and guide you through the installation of these. Now, typically, you will first not see any devices here. To see them, you will first have to go over to your smartphone and enable USB debugging. Navigate to the developer options on your Android phone and enable the USB debugging option. As soon as you've done that, you can again plug it into your PC, hit refresh here, and then the drop-down list should contain the name of your smartphone, which you can now select. Before we can hit build and run, we'll first officially have to switch to the Android platform, which again might take a while, especially when doing this the first time. Okay, Unity is now finished with switching the platform, but we have not yet actually built the app. If we hit now build and run, we have to select a location where we want to build the app to on our local machine and give it a suitable name. I will call this one Microsoft Mixed Reality Demo App and hit save. This will start the building process, and if you have selected your smartphone here, it would also automatically copy the APK file into a suitable folder on your smartphone and even start the app as soon as it is done. This might now take a while again, especially if you're building it the first time. If you would have clicked only build on the bottom here, you would only have built the APK file, which, as we have seen in method 1, you could now manually copy to the smartphone or distribute in any other way. Now, if Unity then writes building a Gradle project, that means that it's building the last, it's at the final stage of the building process, then it will copy the APK package to the device, and in parallel I started the recording on the phone, and you will automatically see the app popping up and showing you the actual app content. Now, if Unity then writes building a Gradle project, that means that it's building the last, it's at the final stage of the building process, then it will copy the APK package to the device, and in parallel I started the recording on the phone, and you will automatically see the app popping up and showing you the actual app content. Now we will discuss how you can use the Android app and how to configure it correctly. After the splash screen, you're asked to input the IP address of the host machine running the Docker container, or if you have the real Jackal robot, of the Jackal robot. Please also make sure to add this WebSocket string at the front, because this is required for the ROS bridge. The port 9090 is the standard port. If you haven't mapped it to something else, then this is what you will enter here. We will have a more detailed documentation on our GitHub wiki on how to find out which IP address your host machine running the Docker container has. After hitting next, you're asked to input the Azure Spatial Anchor's account ID, key, and domain. Please make sure that these are actually correct. We will not add a current Anchor ID because we will create one in this quick tutorial. After hitting Let's Go, you will see a screen very similar to this. Here you can see a 3D model of the Jackal robot. The blue thing here is a map waypoint marker to send the robot to a target location. This here is the origin of the Unity app, and the orange cube is the target indicator where we will place the spatial anchor later on. On the bottom, you can see some UI to interact with the robot, and on the top right, there is a button to open the menu, which hides a few more options. If you hit Tab Screen to set target on the bottom right, you can now place the waypoint marker somewhere on the horizontal plane at the level of the Unity app's coordinate system here. If you now click Toggle Rotation Mode, it will display these arrows, which you can use to grab one of these spheres to rotate the waypoint marker. After hitting Set Goal, the robot will now navigate to the waypoint marker,
which will happily jump up and down upon arrival. You can, of course, do that multiple times and play around a little bit with the app. The orange line is the local trajectory that is used to navigate by Jackal. Now, in order to create a spatial anchor, we will now tap the orange cube with our finger, tap and keep it pressed, and put it somewhere on the floor. Make sure that it is somewhere actually on the floor, because it makes much more sense if Jackal is driving on the floor. Of course, later on, the real Jackal, standing right there, will localize against the same spatial anchor we will create right now, such that the 3D model's hologram will overlap with the real Jackal robot. If you now open the menu and click Create as an Anchor, the coordinate system will snap onto the previously positioned orange cube, and the anchor will be created. The anchor ID is saved to the player reference settings, to the player preference settings, such that it will be loaded automatically the next time. It will also be saved to a JSON file, which you can extract via the USB connection. Now that the world is anchored to our new spatial anchor, you can go ahead and send the robot on its mission. In the app, we added a small green robot arm that you can use to play around and get to know the benefits of augmented reality. This robot arm has an orange cube at the top, which you can take and rotate or move however you like to use the robot arm. It can also theoretically interact with the Jackal robot. And yeah, that's it. In the next tutorial, we'll learn how to locate a spatial anchor. To locate a spatial anchor you previously created or somebody else previously created, enter the ID of the spatial anchor in this box in the configuration screen. If you have done that, and if you then click Let's Go, the app will not automatically locate the anchor. Instead, it will wait for you to manually invoke this feature. So if you now hit Open the menu button and click Find as an Anchor, it might take a second, but after you have waited long enough, the Asian anchor we just placed previously on this point here is located, and the world snaps back to its position. You can now, of course, again take the waypoint, rotate it however you like, and hit Run, such that the robot drives there.
In section number 3, we will talk about how you can build and deploy the demo app to a HoloLens or any other UWP supported platform. First up, you will have to install Unity for this step. So head over to the Unity Hub. You can find links on our GitHub wiki where to find all of these applications. Head over to Installs. Make sure that you have version 2019.4.10f1 installed. If not, you can click Add and either find it in this list, or if it is not there, go to Download Archive and find the specific version there. After it is done installing, click here to add modules. Scroll down to Universal Windows Platform Build Support, check this box and install it. This might take a while, but is necessary to build for HoloLens. Then you can head back to Projects, click Add, and navigate to the folder where you cloned our GitHub repository to. There will be a folder which is called something similar to Microsoft MR Demo 2 or any other name, but it will be very clear which folder you will have to click. In any way, if you open this folder, it should have an asset folder, library packages, and similar things. but then simply choose the folder which is on the root level of the GitHub repository. Now I have it in my list already, so if you have done that, click here, and this will then open Unity, which might take a while, especially on the first load. In order to build for HoloLens, we do have to make a tiny configuration change first. So under Scenes, go to the Manager scene and click it twice. On the top left here in the hierarchy, you should see the Manager scene and a default lighting scene next or above each other. In here, you should see the game object Mixed Reality Toolkit. If you click that, on the right-hand side, the inspector should show you the Mixed Reality Toolkit, and here you can select different profiles. For building for the HoloLens, we will now click the Custom HoloLens 2 Mixed Reality Toolkit Configuration profile. This just applies a few changes which are necessary for HoloLens. After that, click on File, Build Settings, and make sure that these 4 scenes, so the Manager scene, the Demo 2 scene, the Default Lighting scene, and the Configuration scene are checked. It is very important that the Manager scene is the topmost with the ID 0 back here, because it will be the startup scene of the app. Then down here in the platform section, you can select the build target. In our case, that is Universal Windows Platform. If you have installed the platform support correctly, you will see a UI like this. If not, you will only see 2 buttons, where one of them tells you how you can install the build support for this platform. These build settings should be configured as they're here. If not, make sure that you're building a D3D project and in release mode, not in debug mode. Everything else should probably be fine. If you now click Build, Unity will ask you where to build this app to. Here, just create a folder wherever you like. Mine now is called UWP Builds. Select a folder, and Unity will start building the app. For your information, Unity does support delta builds, so if you select the same target location for your builds every time, it will speed up the builds massively. So you will probably see that my build here is a bit quicker than the first time for you building the app. Still takes a while though. As soon as the Explorer window here opens, Unity is done building for the UWP platform, but this only generated a Visual Studio solution. You will now have to open this .sln file with We Suggest Visual Studio 2019. You can find download links in our GitHub wiki again. After opening the scene, make sure that you configure Visual Studio for in release mode to target ARM64, and here select the device. Now plug in your HoloLens and switch it on. Up here, go to Debug and click Start without debugging. Visual Studio will now generate the necessary files and copy them over to your HoloLens. This might take a while again. If you see deploy succeeded down here, the deploy succeeded. After you're done with building and deploying the app, there is still one more thing to do to set it up correctly. Head over to any Explorer of your choice and type in the IP address 1.2.168.1.143 to visit the remote access to your HoloLens and log in. On your HoloLens, you can now navigate to the File Explorer on System, File Explorer, go to Local App Data, MS IROS Robot Interaction Demo, Local State, and in here you will have to upload a file. This file, you can choose it here, go to your credential files. We'll look how this looks later, but select upload such that the file is here. It has to have this exact name, asa_account_config.json. And we will now look how this file actually looks and what it contains. So this file is a JSON file which contains your Azure Spatial Anchors authentication data. So it has 3 fields. One of them is account ID, account key, and account domain. You will find example JSON files on the GitHub wiki as well. Please enter your things here. Now, after uploading this JSON file, we can start the app on the HoloLens.
I will now show you how to use our robot interaction demo app on the HoloLens. First up, open the menu, go to All Apps, and click MS IROS Robot Interaction Demo. Please note that it's important that before doing that, you have to upload the configuration file as just discussed in this tutorial. The first thing you will see is the IP address input screen. So if you're not happy with the IP address that is in here, you can click Edit, which will open this keyboard. You can now navigate to the location where you want to change something and do that accordingly. As soon as you're done with that, click Save. If you have uploaded the configuration file correctly, you should see a scene very similar to this. For your, just to quickly show you around, up here, you can see the 3D model of Jekyll. This is the waypoint marker. Up down here is the coordinate system of the Unity app. And this green thing here is the robot we added for additional interaction. Here you can see the menu, which you will use to interact with this app also. First, in order to move the waypoint, let's first create an anchor. To create an anchor, take this orange cube and position it somewhere on the floor. If you have done that, you can look over to the menu and click Create as an Anchor. As you can see, the Unity app just snapped onto the orange cube and everything is placed to there. Also, the anchor ID is saved to the JSON configuration file we just uploaded via the remoting. Now, in the Unity app, we can remove this cube here, remove this out of the way. Now we can interact with this waypoint marker and put it somewhere where we want the robot to move. By rotating the hand, you can rotate the waypoint marker. If you now want the robot to drive to the position, tap on Set Position, and Jekyll will drive there. Similar to the Android app, the waypoint marker will happily jump up and down as soon as the robot reaches its goal. Now, to interact with the green robot, you can simply take this orange cube and rotate it, or simply grab the complete cube itself. And you can just grab the cube, move it around. For example, we could now command Jekyll to drive here. Maybe a bit further down there. And now the robot could, for example, position something on the Jekyll or take something off or whatever, and Jekyll can drive away again. Okay, that was creating an anchor and interacting with the app. We'll now quickly discuss how to find an anchor, which is similar easy. Let's locate the anchor again. Okay, we located the anchor we created earlier. Now let's test a second alternative way of interacting with our virtual robots. First, let's locate the anchor again. Okay, we just located our anchor. By pressing the toggle control mode button, which in a very similar manner also exists in the Android app, we toggle the control mode to our new alternative and maybe also more intuitive way of controlling Jackal and the industrial robot arm. This hand model, which you can see here, is bombed. The user can now grab the hand model and position its pose however the user would like, and the robotic arm will try to match its end effector with the pose of the hand. Now, for precise manipulation, the user can use the near interaction like this, but also, and this is where the power comes into play, do a distance interaction and move the hand somewhere where the user himself cannot reach. And since the green robot won't reach, the Jackal base will drive over to the hand such that the green robot can actually reach its target. And now the user can, without leaving the workplace, do farm manipulation task, for example, pick up something from this box over there, and put it into this box here.
Now we are already in our last and fourth section of this tutorial, where we will have a brief overview of the actual Unity app, and I'll tell you a few things where you can implement your own features or work with your own robots in your robotic project. First up, this is Unity, and on the left hand side you can see the hierarchy, which displays the structure of the current scene you're looking at. In the center you can see the scene view itself, and on the right hand side is the inspector, which shows you more details about the selected object from the hierarchy. On the bottom you can see the project overview, which is basically an explorer where you can store files and scripts. First, head over to the Scenes folder and select the Demo2 scene. As you can see in this scene, this is basically what you're seeing on your smartphone or on the HoloLens, and it contains a few important things. Most important is the parent anchor, which is used for the Azure spatial anchor. Everything in this scene, so all of the robot game objects, are children of this parent anchor. That makes sense because as soon as you find an anchor or you create one, this object is moved to the anchor's location. And if all the children of an object move with the parent. That way we don't really have to care about the individual placement of all of these components and only have to care about the placement of the parent anchor. The parent anchor contains the robot space location, which is an object that contains the actual robot, so our Jackal, the move base target, this gold marker here, and another object that shows the robot trajectory as soon as Jackal is navigating somewhere. This axis object here shows us the origin of the Unity app, and the industrial robot back here is just our robot that we're using for an enhanced experience. The anchor dragging box is this orange box that you can use to create new anchors. On the parent anchor, we have different scripts. One of them is the ASA controller, which has all of the code to create and find anchors. Next up, we have the ROS connector. The ROS connector is a game object which doesn't have any visual or physical properties. It just holds a bunch of scripts, a few subscribers and publishers, and that each have individual tasks. Most important probably is the odometry subscriber, which subscribes to Jackal's pose in the gazebo world. It also directly applies this pose to the Jackal game object SpaceLink. Then we also have an executable stamped pose publisher, which we can trigger, which then publishes the goal points pose to the Autumn frame in the topic MoveBase simple goal, which then basically tells MoveBase to calculate a trajectory where the jackal should arrive. There are a few different other publishers and subscribers, which we don't have to go into detail now. In our GitHub wiki, we do have a detailed explanation on how you can create your own custom subscribers with custom messages. It's not at all hard, and yeah, you can read more about that there. Everything else, for example, this hand menu is simply the menu you saw in the hologram in the HoloLens app, and it is rather basic stuff. To read more about the Unity app's structure, you can head over to the GitHub wiki in our repository and start reading in the repository overview chapter 2.1. Here we have a list of dependencies, which branches do what, and all things like that. We also explain how to implement your own robot in our Unity app, how to add multiple robots, it is not constrained to one robot, and also how to expand the actual MR app to have your own features and to help you in a meaningful way. That being said, thank you very much for listening to our tutorial on mixed reality robot interaction. We hope that you learned something new and that you can use mixed reality in your robotic project.